Okay, so to have this more accurate estimate of it, you should, take more concentrations in between 0.125 to 0.25 and plot them on a graph like 0.125 to 0.25, and this would make some calibration curve. And here, uh, you will plot a number of seconds taken here. Okay, uh, at each concentration to number of seconds taken for first appearance of color change. Okay, so for P you will have recorded some number of seconds for the first appearance of color change. You will use this calibration curve, draw a horizontal line and then a vertical line, and you will take a more accurate estimate from this by using this calibration curve. So this may be included in your this answer. uh, a scientist studied the change in the concentration of glucose in blood plasma after eating a meal containing carbohydrate. Samples of blood plasma were taken at regular intervals after eating the meal, and the concentration of glucose in each sample was measured. The results are shown here. Time after eating the meal, this, and concentration of glucose in the blood plasma is this. You are required to use a sharp pencil for graphs. Uh, For making a graph, you should remember we use OSLP, orientation, suitable scale, labeled axis, and plotting. Okay, so the first thing we should do is that independent variable should be on x-axis and dependent variable on y-axis. Independent variable in this case is time after eating the meal in minutes, time after eating meal in minutes. This is independent variable. And concentration of glucose in blood plasma, millimole per dm cube with the units, that is the dependent variable. Glucose concentration backslash millimole per dm cube. So this is labeled part, so you will get 1 mark if you have labeled it. Okay, it is correct orientation, so you will get another mark. Then you have to take a suitable scale. How you should take suitable scale? On x-axis first, as your values range from 0 to 80, and this has 1, 2, 3 and 4 boxes, so you will have 20, 40, 60 and 80 and 0. Okay, so you have each box with an interval of 20. This is a suitable scale. The whole year values have been distributed on x-axis. Similarly, on y-axis you should take if it is 5.125 to 7 maximum is 7.60. So you should see 1, 2, 3, 4, 5, 6. You have 6 boxes. So if you start with 5, this is a little complex. Try doing it yourself and then make a graph. I'll explain it later. Calculate the percentage increase in concentration of glucose in the blood plasma between 0 minute and 20 minutes after eating the meal. You may lose marks if you do not show your working. Whatever the graphs you will have plotted, so this is 0, you should pick up the value from 0 and pick up the value at 20. Take a difference of that and divide it by the initial at 0 multiplied by 100, so that would give us a percentage increase. Use one label line and the label X to show on the graph where the rate of diffusion of glucose into the blood is the most rapid. uh, use one label line and the label X to show on the graph where the rate of diffusion of glucose into the blood is the most rapid, where the concentration in the plasma is the highest. No, where the concentration in plasma is the lowest. Okay, use one label line and to show the graph where the rate of diffusion of glucose into the blood is yes, where the glucose concentration in the blood plasma is the lowest, that will have the highest rate of diffusion. Suggest one reason for the concentration of glucose in the blood plasma decreasing between 60 minutes and 80 minutes after eating the meal. So maybe as question is beginning with suggest, so maybe it has been absorbed by the cells and converted into glycogen, or maybe used during respiration. I hope you have understood it. If you have not understood anything, please bring your question paper in the next class on Monday. So we'll discuss it on Monday. Thank you very much.